Hey everyone, Morgan here. So we are working on page 10 of the honors outline dealing with thermodynamics. And we are working our way towards a discussion of the concept of spontaneity in a chemical reaction. So, does your room spontaneously clean itself? The answer is no. You have to do work. And anytime that you have to do work for something to happen, it is not spontaneous. It is non-spontaneous. In fact, we will consider that a spontaneous reaction is one that proceeds without outside influence from the rest of the universe. Okay? Now, there are three factors that are going to come into play here when we're dealing with spontaneity. They are the enthalpy, entropy, and temperature. And we already talked about the temperature effects on spontaneity. Okay? So, imagine you have a piggy bank and you hold it up over your head and you hit it with a hammer and all the coins fall out of the piggy bank. When they hit the floor, do you end up with stacks of quarters, stacks of pennies, stacks of nickels, stacks of dimes? No. You get a mess. The coins go all over the place. Okay? And what this tells us is the coins fall randomly. Okay? They don't fall in a nice, neat stack, so that you kind of understand here, an organized system requires work on your part. A disorganized or dispersed system is one that's going to occur spontaneously. And this was taken into account, all three of these factors, these ideas, in something called free energy. Free energy is the energy available to do work. And if that's doing the work, then you don't have to. This was first mapped out by a guy named Josiah Willard Gibbs, so often we call this Gibbs free energy. Our symbol for it is delta G naught. So what you are hopefully catching on to by seeing that this is a capital G is that free energy is a state function. Okay, we most typically do it under standard conditions, and we are much more interested in the change in free energy than in the free energy itself of a specific species. Now, the problem with trying to understand free energy is that it's not a tangible item. It's not a tangible thing. I can't go into the grocery store and buy a bottle of free energy. That doesn't exist. It is keeping. It is a way that we keep track of the three factors, enthalpy, entropy, and temperature. Okay? So we'll say that a reaction is spontaneous when you don't have to do work, or when delta G naught is equal to a negative number. Okay? That means the free energy has come out of the system and it's able to do the work to drive the reaction so that you don't have to. Okay? So, free energy, it's a state function. Okay? Since it is a state function, we can do products minus reactants. But most of the time when we're going to calculate it, we use the Gibbs equation, which is delta G naught equals delta H naught minus T delta S naught. And we will visit that some more on the next page of the outline. Thanks for tuning in. This is Morgan, signing off.